First 20 seconds of that. Alright, 5.7. Like some of you already know, this is one of the harder things we do in this class. Alright? So, we got to make sure that we get it because this, of course, it'll be on your test, on your semester exam, those sorts of things. But it's also, this is one of the things that you use very much in classes as you move forward in math. Okay, like there were people who were in my class last year that came and told me like first 6 weeks that they were using completing the square in Miss Mitchell's class. Okay, and they'd kind of tried to block it out of their minds because they didn't like it, and then all of a sudden I kind of bit them because they had to use it. All right, so remember that this is important, and you really need to be able to understand it. The more you understand why it works, the easier it will be to follow the steps. All right, so the point, what we're doing, it's called completing the square, and the point is to solve quadratic equations. We have already learned some methods to solve quadratic equations, and one of them is graphing. So if you have a graph like this, and I say solve it, what are you looking for? The x-intercepts, here and here. So you'd have two answers for that one. Another way your graph might look is like, it almost touched like that, where it just touches one time if the vertex is on the axis. Another way is like this, where it never touches. Okay, so you have no real solution, but you do have imaginary solutions, complex solutions. All right, so the ways we have solved quadratics before is graphing on the calculator, and you told the calculator find those points. Okay, but your calculator cannot find the imaginary points. It's just not that good. All right, put your phone away. It's just not that good. So, and factoring is another way that we learned how to solve. You did that right before Thanksgiving break, and that also, you cannot find the imaginary solutions with that. So that's where completing the square comes in, is that it's necessary for that. Completing the square also works when you have real solutions, but it works when you have imaginary solutions. So, let's look at this. Here are your steps. Okay, it may be easier for you to look at it as words. It may be easier for you to look at it written out like this, or the third empty column, we're actually going to do our first example there, so you have everything side by side. All right. To start, we get it set up in standard form. So that's ax squared plus bx plus c, and then you can have a number over here. All right, is our example set up that way? Yes. All right, so we're good. Step 1, we need to make a equal 1. It says if a does not equal 1, at the very beginning, divide all terms by a in order to make a equal 1. And that looks like this. Everything's divided by a. But the question you ask first is, does a equal 1? So over here, what does a equal? 1. So we get to skip step 1 for this problem. A equals 1. Next step, let me read it. I'm going to zoom in and out a lot today. It says move C to the right side of the equation. So what is our C? Negative 20. To move it to the other side, what will we do? Add it. Okay, so we have 20 plus 0 on that side. So we will be left with x squared plus 8x equals 20. You okay so far? This is all just getting it set up so we can work some magic, almost, basically, here on this next step. Easy so far. We're going to add b over 2 squared to both sides of the equation. That is our special magic number that makes it all work. B over 2 squared. Our this is the one that we need. We need it on this side, but in order to keep the equations equal, we also put it on the other side. We have to figure out what b over 2 squared is before we can add it, though. So we've got b over 2 squared. What is our b term?
8.
8. So 8 divided by 2, what is that?
4.
4. So we have 4 squared, which equals 16. Thank you. So our 16 is going to go right here and right here. So when we write it out, we'll have x squared plus 8x plus 16 equals 20 plus 16. Now what we just did was create a perfect square trinomial on this side. And that means that if we factored this, you'd get two of the same factors. So you'll write that one factor and then squared next to it. Now, we can follow the steps and do like our big X and AC on top, B on bottom. But the way we work this is that it'll be the same thing every time. So you don't even have to do all those steps. Every time it will be X plus B over 2 all squared. Your B over 2 is this number before you squared it right here. So that 4. So we write X plus 4 squared. We just, basically we factored this.
Wouldn't it be 2?
No.
4 over 2?
It's 8 over 2, which reduces to 4. B was 8. Divide that by 2. And that's what goes here. If you don't...
That we divided after, like, before we square it.
Yes, so this number right here is what goes right there. All right. Now, the other side, just simplify it. 20 plus 16 equals 36. This equation, if you graphed it, would be the exact same as the equation we started with. We're only changing the way it looks. All right, we
Where did you
change.
get the 36 from?
20 and 16 added to be 36.
Oh.
Good questions. This b over 2 squared number that goes in here makes it possible for this to be a perfect square. It's something squared. And every time that something will be x plus b over 2, whatever b over 2 is. From here, we solve for x, which is like what we did at the end of yesterday's notes. And to start out, let me just zoom in here. Let me write down what we've got, and then we'll mess with it. The first thing we need to get rid of is the squared. So how do we get rid of a squared?
Square root.
Square root. If we square root that side, got to square root the other side. What happens between the square root and the squared?
We can't add.
They cancel, and we're just left with x plus 4. When you square root both sides, what sign has to go in? Plus minus. And then what's the square root of 36? 6. It's getting a lot simpler. All right, well, we're still trying to get x by itself, so what should we do with this plus 4? Subtract it to the other side. Just for reducing confusion's sake, always put stuff in front of the plus minus. Leave the plus minus at the very end so it doesn't get confusing. So we'll have x equals negative 4 plus or minus 6. Are negative 4 and 6 like terms? Yeah, they're both just numbers. So let's write it out. So we'll have negative 4 plus 6. we'll have x equals -4 minus 6. That way we can go ahead and get single numbers as our answer. So we'll have x equals, what do you get? 2 and -10. And those are the two places where that parabola crosses the x-axis. So that is completing the square. Now I want to do more examples with you, so we're going to do 2 off of your homework together. So if you want, go ahead and get your homework paper out, and then we'll keep going. Number. Hello.
You can't get me excited to
No.
start doing math and then just kidding.
All right. Number 13, it says x squared minus 3x equals 28. So, first step, what does A equal? 1. So can we skip first step? Yes. Okay, second step, move C to the right side of the equation. What's C?
28.
It's already there.
Oh, wait.
C either already got moved or C was 0. Either way, all the numbers are on the right side of the equation. So skip that one. Go to step 3, where we add b over 2 squared to both sides of the equation. So let's figure out what b over 2 squared is. Well, what's b? -3. So we have -3 over 2 squared. Can we reduce that fraction any?
Yes.
No. So just square the top and square the bottom. So what's -3 squared? 9. And what's 2 squared? 4. So our special number here is 9 over 4. And we add that behind the 3x and behind 28. So we have x squared minus 3x plus 9 over 4. Keep it as an improper fraction.
Why?
Why? Because I said so.
Because she got a degree. She said so.
It's true. I do have a degree.
English
She
teacher,
wins.
man. That's the only thing that ever bring up. I've got a degree. That's why I got to do it this way.
And then she wins. You
did
can't
it all
say
the
nothing.
time. I have a degree.
Okay.
You have a degree.
Okay. So that was step 3. Step 4. Factor the left side. It will always be a perfect square of x plus whatever b over 2 was, all squared. So we have our parentheses, and we're going to have squared. X goes first, and then b over 2. What was b over 2?
9 over 4.
Not b over 2 squared, but just b over 2.
-3 over 2.
-3 over 2. So we have x minus 3 over 2, all squared.
I'm smart.
It wouldn't be wrong if you took it out of fraction, would it not?
We're not done yet.
They don't.
But, it makes it harder later in the problem, when they're not perfect.
Alright, you
I'll show
done
you.
confused me now.
Well, I'm talking to him.
Just ignore
So
it.
just ignore all that?
Yeah. Okay, but we need to add these two together. You can do it in your calculator and get a fraction back, or we can do it by hand. Okay, what is that as an improper fraction? I'll do it by hand, I guess. Put this over 4. 28 times 4, I believe, is 112, which gives us 121 over 4, which calculator can do that for you. If you have questions about how your calculator can show you a fraction, I can help you with that later.
Don't you just hit the frac button?
Math, and then frac.
Frack.
I like it.
All right.
That's an improper.
Anybody have questions through step 4?
Negative goes right there.
What do we do next?
Step 5.
Square root.
Square root both sides,
Oh, shady.
because we're trying to solve for x. So what do I have left on the left?
Thanks. -3 over 2.
X minus 3 over 2, yep. What's left on the right?
I don't know yet.
Well, first of all, what's the signs you have to put in there?
Plus or minus?
Plus or minus. What's square root of 121?
11.
What's square root of 4?
It's 5 and
2.
2 fourths.
Is it really?
5.5.
That's what I'm
It's
talking
11 over 2.
about.
Okay, now we just need to get the x by itself. So what do I do with 3 over 2?
Add it.
Add it, since it was being subtracted. So that gives us x equals positive 3 over 2 plus or minus 11 over 2. Those are both real numbers. We can add them, combine them. So x equals, I'm going to write it with a plus, and then I'll write it with minus, and we'll figure them both out.
14 over 2.
Yes, the first one is 14 over 2, which is x equals 7. Next one, negative 8 over 2, which is negative 4. You are geniuses.
You know, smarter now than I was.
Mm-hmm.
No, we're doing that.
Try to get the whole problem on there for you. There's the whole problem.
Pretty
All right, so we're gonna do number 21. I've written it up there. Is anyone not ready to keep going? All right. So first step, our problem's supposed to be set up in like standard form. Like, which is supposed to come first, x or x squared? X squared. I'm thinking it'll be easier for us to look at this if we have it written with the x squared first. So I'm gonna write negative 3x squared plus 6x equals negative 12. I'm just gonna mark that out.
Wait, why do we square everything?
All we did there was just switch these two, just so that the x squared came first, because that's what we're used to. All right, step 1 was about a. Is a what we need it to be? No, what's it supposed to be? What is it? Negative 3. So over on the directions it says if it's not 1, just divide everything by a. So we're going to divide everything by negative 3. The negative 3's should cancel for the x squared. So we're left with x squared. What's 6 divided by negative 3? So negative 2x equals, what's on the other side? 4. All right. See, it looks a lot better. Let's see. Step 2 told us to move C to the other side. Do we need to do that?
Absolutely.
It's already done, right? It's already over there. So we get to skip that one again. Cool. Step 3 is figure out our special magic number, b over 2 squared. So we need to figure out what b over 2 squared is.
Negative 2 over 2.
Negative 2 over 2. Go ahead and reduce that to negative 1, right? What negative 1 squared is
I.
1. Square root. Where do we put that 1? Now,
Behind each side.
behind each side. Very good. So we get x squared minus 2x plus 1 equals 4 plus 1. It went right there and right there. What's next?
The x squared
negative 2 over 2, which when we reduced that, it was negative 1. So that's what we use to go right there. So we say x minus 1. And then the right side is 4 plus 1, which is 5. And then square root. The square root and the squared cancel out, you're correct. X minus 1 equals what? Plus or minus square root of 5. Can we simplify square root of 5 any? No, not without going to decimals, and we prefer not to. Or I prefer you not to. So, leave it as plus or minus square root of 5. Alright, what's next? Getting x by itself, so
You can take the square root of 6,
no. What should I do, Melissa?
doesn't work like that.
Sorry, it's hard to hear. Add 1. Yep. So we get x equals, I'm going to put my 1 in front of the plus minus to keep it organized. And without making a decimal, we can't combine those, so that is your answer, or those are your answers, because you actually have 2. There's at least one of the problems, I think it may be 15, that you get,
3 answers.
no, you get I in your answer. You get an I in your answer, just FYI. There may be another one.